Okay, let's look at this Newton's Law question from the supplementary paper, February-March 2018. So it says two boxes, P, here's P, and Q, resting on a rough horizontal surface, are connected by a light inextensible string. The boxes have a mass of 5 kilograms and 2 kilograms respectively. A constant force F acting at an angle of 30 degrees to the horizontal is applied to the 5 kilo boxes shown below. The boxes now move to the right, okay, at a constant speed of 2 meters per second. So if we are at a constant speed, we are at equilibrium, my acceleration is going to be 0. State Newton's first law of motion in words. So this is the inertia law, so that if you are at moving, you want to keep moving. If you're stationary, you want to stay stationary unless a net or resultant force acts on you. So learn your definition and state it correctly. Now it says draw a labeled free body diagram for box Q. This one is box Q over here. So let's draw the free body diagram for Q. The first thing that's happening on Q, okay, first of all, let's draw the little blob so that we know where the center of our free body is. The first thing that's happening to Q is we have its weight acting directly downwards, weight or the force due to gravity Fg. It is on a surface, so it immediately has a normal force acting upwards. It has a string attached to it over here, which gives you tension, and then they said to you on a rough horizontal surface, so we know that we have friction, which is opposing motion, and motion is to the right, so friction must be to the left. And it's 4 marks, so we have 4 arrows all coming out of the dot, drawn with a ruler, each with an arrowhead and a label. No label, no mark. Correct label must also be used. Now it says you calculate the magnitude of force F. This is actually worth 6 marks. Okay, so you know it's not just a one and done, easily answered. So for 6 marks, we have to figure out what's going on. Now, the first thing, the moment you have 2 blocks, you need 2 diagrams. You cannot ever solve these questions with only 1 diagram. So we come here, and to help us solve it, we're going to draw block P, which has its weight going downwards, its normal force going upwards. It has this applied force F, which you make sure is at an angle. And then coming behind you here, we have the string which has a tension T. But now remember, block P is also on this rough surface here. So block P is also experiencing friction. So there are 5 forces acting on block P, whereas there's only 4 forces acting on block Q. So what do we need to know? We want to calculate this force F, which is acting on block P. But we don't know everything about block P, but we do know things about block Q, okay? Because they came and they told you block P's got 5 newtons, so if we wanted to, we could put the 5 in there. And box Q has a frictional force of 3 newtons. So have a look at this box Q here. You can only add forces that are in a straight line. So T is going forward, F is going backwards, and my block has an acceleration of 0. So we can say for block Q, and now make sure you label your calculations like this. For block Q, F net equals ma, but my ma is going to be 0 because the acceleration is 0. Okay, and we can also write to the right is positive, yes? Okay, so my block Q has got my tension, which will be positive, and my friction, which will be negative. So T minus F equals 0, but they said F was 3, so T minus 3 equals 0, so T equals 3 newtons. Now this is handy to know the tension, because the tension pulling this way out of block Q is exactly the same as the tension pulling that way out of block P, because tension is the same everywhere in a string, even though it's in different directions. So now once we know this for block Q, we can go start working on things for block P. Okay, the first thing we have to look at for block P, you may only add forces if they are in a straight line. Now I ask you, is F in a straight line here? No, F is not in a straight line, which means we have to use F's components. So the X component, see, F has got these two components, Fx and Fy. The X component is in a straight line with the tension and the friction, which we have a value for. So for block P, F net equals MA, which is going to be equal to 0, okay, because the block is not accelerating. So Fx, we said to the right is positive, so Fx is positive. Fx minus T minus F, and remember this is Fp, is going to be 0, and we found the tension was 3, so Fx minus 3 minus this 5 that they told you about in the question is 0, so Fx equals 8. Okay, but remember Fx is the same as saying the force F cos the angle, so F cos 30 degrees equals 8. So F is going to be 8 over the cos of 30, which should give you 9,24 newtons. And now it said calculate the magnitude, so we don't actually have to give a direction, but it is to the right and up, but we don't actually need that bit. So the force is 9,24 newtons. Okay, so then we have a look here what else is going on with these two blockies. It says to you the string connecting P and Q suddenly breaks, so it's this string here, suddenly breaks after 3 seconds while force F is still being applied. Learners draw the velocity time graph for the motion of P and Q before and after the string breaks as shown below. Write down the time at which the string breaks, like hello, it says after 3 seconds, and if you look on the graph here, everything was moving at a constant velocity until 3 seconds. So the string broke at 3 seconds. Now, which portion X, Y, or Z of the graph represents the motion of box Q after the string breaks? Use the information in the graph to fully support your answer. Now, have a look here at these two blocks again. Imagine these two blocks. They're being pulled along the table by this string here, and then this string breaks. And presumably this force is going to keep pulling box P. But now what is pulling box Q? Nothing anymore. But what is happening to box Q? There is still friction slowing this box down. So we need to figure out which section of the graph shows something slowing down. Now this is a velocity time graph, so acceleration is the gradient. So this part is speeding up, okay, after 3 seconds because the gradient is increasing, and this part is slowing down. So box Q is going to slow down because friction, okay. So this portion of the graph is this portion Y. So for 2.5, Y is the motion of box Q. Use the information in the graph to fully support your answer. Okay, so the graph has a negative gradient. Okay, the graph has a negative gradient which indicates deceleration. Okay, deceleration, that looks wrong, as friction is slowing the box down. Okay, or you could say no more tension as well for friction slowing the box down. No more tension, or friction is the only force on the box. There we go, and that question is now fully answered.